Hello, everybody. Okay, so this is Kokkos Ecosystem 4.6 release briefing. So I'm going to start with a few high-level announcements, and then the guys are going to take it away and give you all the information about the new features that were added, general improvement we had to the library since 4.5, and anything you probably should be aware that changed. Feel free to ask questions if you have any, and then we'll have a separate presentation that will go over the updates from Kokkos kernels. Okay, so let's get started. Yeah, as always, you can find us on the main organization is on GitHub. That's where everything happened. We don't have any hidden forks. This is the source of truth, the develop branch over there. You can find all our tutorial and examples if you navigate from the main website and look for the material. And yeah, if you haven't already joined us on Slack, you should consider doing so. That's usually the good place to ask your question or check maybe if you're unsure before opening any issues, or if you want feedback on whether someone is working on something or whatnot. And we have sections in our documentation on how to join if you have problem. Anyone, if you're already a member, you're able to invite your colleagues or people you know. And if somehow you don't know anyone, you can still contact directly either Christian or I. You'll find our emails in the license files. Okay, so still a standing slide. So we would like to be able to advertise how many application users, and it's been quite difficult to keep track of all of you. So we have this outstanding issue, which is actually pinned. If you go on GitHub, Kokkos, you'll see in the issue it's a pin issue. So if you haven't already, you can list your application or library. There's a few fields. It's like essentially filling a column for a table, and we are planning on soon migrating this thing to the main website. And another thing that you might have seen when you navigate repos, there's these little labels or tags on the right hand side that you can add, and there is a Kokkos tag, a Kokkos topic. And if you haven't done so, I would appreciate if you used it because it really helps with discovering just for us in the first place, but also other people might be able to discover you a bit easier if you use that topic. Okay, so now things more specific to now. So I'm going to cover the upcoming Kokkos user group meeting and some of the important changes that are coming. So if somehow you haven't heard about it yet, so next month we will be holding our third Kokkos user group meeting. It will be in Chicago, Illinois. May 5th through the 8th is the HPSF conference, but the Kokkos user group meeting is specifically on the 7th and 8th. So you can still register for it. It's open. We would love to have you if you are not already registered. What to expect? So it's going to be the first 2 days are going to be generic information about the High Performance Software Foundation. You should definitely come for this to get a feel for what all this is about if you're not already familiar with it, but also see what has been done since the launch last year. And then so about the Kokkos user group meeting. So here, what to expect. So we're going to have 2 times 4 90-minute sessions. And essentially, it's going to be a very exciting blend of talks from the members from the Kokkos ecosystem and community users, some experienced users that you've seen before, but also a large number of new voices that you have never seen before. So it's pretty exciting. So the first day, we're going to kick off with essentially updates from the team. And then we try to bucket a bit some of our talks. The first session the second session in the morning is going to be essentially how Kokkos is used mostly in applications. Then in the afternoon, you'll have more of talks talking about transition to Kokkos. And we'll close the day with lightning talk sessions, which is really packed. It's going to be exciting. And so the second day, we're going to kick off with a number of talks that are from the ecosystem. So people who are affiliated to the larger Kokkos developer team. Then we'll have another session I'm looking forward to, the tuning and performance one. How when you already run on Kokkos, how you can make your application or library run even more efficiently. Then we'll have a section that focus on algorithms, and we will close the Kokkos user group meeting with a panel discussion. We haven't announced yet the composition, but essentially it's going to be a blend with people from the developer team, from core, from kernels, from the broader ecosystem, and we'll have on stage some representatives from the user community. We will be looking at people who work on libraries, on application, and potentially also someone who's more an educator. So yeah, that's a pretty exciting program. And if you're still hesitating, don't hesitate further. You should come and meet us. It's really a good time to interact with the rest of the community. Anyway, so other things at the conference, there will be a general poster session that actually has a few Kokkos specific work being presented. As I mentioned, you get updates from other projects such as Spark, Tradinos, things that are important to a lot of you guys. And we will introduce for the first time some of the working groups, which it's an open community, so you might, if you're interested, you might want to get involved, and so it's going to be your chance to meet these groups and understand what they're about and see if you want to get involved. And there are a number of panel discussions that are going to be interesting. Some stuff about looking back at some of the hardware trends and things like that that are very relevant for us. So yeah, you should come to the conference. Okay. So beside HPSCon next month, if you were planning on going to ISC in Hamburg in June, HPSF again, he's going to have a buff session. And a number of guys of the team from the Kokkos team will be there. Certainly some of the guys from CEA, Christian is going, I'm hoping to be there. So if you're going to ISC, come find us, come talk to us. And other than that, this month, next week, we're going to get the next Sexa Kokkos Tea Time, which is going to be about Solomon. I think the speaker is from Japan, and it's going to be it's essentially an interesting library that propose some unified syntax for directive-based GPU offloading. so which let you have use macros that they define, and then at configure time decide whether you will dispatch using OpenMP target or OpenACC. And so, yeah, it's going to be interesting to see how other people have been trying to solve the portability challenges. Okay, then in case you have missed it, but it's going to be hard to pretend you don't know it's happening. So we're about to release Kokkos 5. So right now, this release briefing is about 4.6. In around July, we're going to have 4.7. And then, so about 4 months later, which will push us sometime in the fall, is going to come. Kokkos 5 is going to come. But it means that when we're going to fork for Kokkos 4.7, we're going to start requiring C++20 in the develop branch. So, prepare accordingly. There's still time if you have special requests on to give feedback on. We are in the process of hardening what the minimum requirements are going to be. But if you care, you can give us feedback on what this minimum requirement should be if you have opinion. Otherwise, just get ready for the transition. Just don't be surprised. That said, as we have done with the transition from 3 to 4, we will extend the support for the 4.7 release for tentatively up to a year. So, which means we will, if there are major bugs being reported, we will backport them, but that will stop there. Anyway, just plan for C++20 at the end of the summer. Another thing that we're just echoing that's been already deprecated in 4.5, the generated make files. So hopefully all of you guys don't care and you're all already using the CMake system. But if you're using make files, we deprecated it, and you should get ready to transition. There is an issue on our organization on the Kokkos Core repo that announces it. And if you have comments or questions, feel free to comment there. Okay. And yeah, we'd like to take a chance to let you guys know that we recently actually achieved the level, passing level on the OpenSSF best practice batch program. And although it's just a pin, it's really capturing part of a larger effort on our side to really improve our processes. So I think someone added it to our README recently, and I guess I'm on the hook to write a very short blog post to announce this. But anyway, well, it's a small milestone towards us improving. Okay, that was it on general announcements. And I think Conrad is next.
Yeah. So now we're going to talk about a couple of feature highlights that we have in this release. Next slide. So first we'll talk about Kokkos Graph. So just to recap, Kokkos Graph describes an asynchronous workload, which is organized as a graph. We have an example here. So we build this graph and we build it using these nodes. So we have node A, which executes a parallel 4 using a policy and a functor. And then based on node A, we have node B and C, which can then run asynchronously after A is completed. They have their own policy and functor, which describes the work being done. And then in this example, we have node D here, which waits for B and C to complete and then executes its own parallel 4. And so this is a diamond-shaped graph here. And then we can submit this multiple times, which will then run the things within the graph. So what's new, so we can go to the next slide, is that we now have a node that we can create, which represents a single call to a functor every time submit is called. And so, yeah, in this new example, we have node A that runs a parallel for, and then node B runs after node A, and it just runs the functor one time. So you can think of it as a parallel for size 1. And so the important part with functors, it has to be callable without any arguments and marked in Kokkos function, and it's executed on the execution space the graph is submitted to. So then next, we have a new interoperability feature, which is that you can create a Kokkos graph from a native CUDA, HIP, or SYCL graph. And so here in our example, we create just Kokkos graph or CUDA graph, and then we have this function create graph from native, where we hand an execution space and the native graph, and it gives us a Kokkos graph. So note that this is in the experimental namespace. So for instance, we don't yet allow adding nodes that created from using the native API to Kokkos graph. So it is experimental, so don't expect everything to be there. And then pre this release, we also have the other direction where from any Kokkos graph, you can get the native graph back. But new in this release is that you can create a Kokkos graph from a native graph. And so then the last new feature is that now multi-GPU is enabled for HIP. This is where you can launch kernels on multiple devices from a single host process. And it's previous to this release, it was implemented in SYCL and CUDA. Now it's for HIP, and it's important to note it's only for ROCm 5.6 and later. If you use it before that, there's no error or warning. It just won't work because before 5.6, there's no way to ask a HIP stream what device it was on. So that's a very important thing to note. It's also a bit of an advanced feature, so it will require direct use of the HIP runtime API because we have to manage the streams. So we have to create and destroy streams and set device and things like that. It is also experimental, and we're always looking for feedback from new users. And that goes for all backends that it's enabled for. And we have documentation there to help get you started. And so for this next slide, we have a small example where at the top, we create 2 streams. We create a stream on device 0 and then a stream on device 1. And this is where I was saying that you have to be able to use these HIP runtime API functions. So once we have these streams, we can create a Kokkos execution space from these streams. And so then any views that we then allocate using that execution space will be allocated on the specific device that the stream was created on. And then we can launch asynchronous kernels on these devices by passing the execution space to our policy. And so now we can run concurrently on the different devices. And then lastly, we need to destroy the streams. And this is another important note that if you plan to use this is because the stream is stored by the execution space, we need the execution space to be deleted before we destroy the streams. And so that's why I scoped the creation of the execution space there. Because if not, then we destroy the stream and we have an execution space in an undefined state. So that's now enabled for the HIP backend. And again, any new users, we would love feedback. And so feel free to reach out if you want to explore using multi-GPU. So next, we'll go to some general enhancements. Let's see, next slide. We fixed a warning from Kokkos check. And so Kokkos check, it checks at configure time that Kokkos was built with the requested backend and target architecture. And there was this warning that we have listed below there when you would call Kokkos check from a package config CMake file. And so that's been fixed. Next slide. We've improved the performance of inclusive scan. So with the CUDA and HIP backends, inclusive scan now will call the vendor versions in Thrust. And so you need to have Thrust enabled. But in that case, then the Thrust versions of inclusive scan will be called instead of a Kokkos parallel scan based. And this is resulting in a speed up. We've seen 1.5 to 3 times speed up on V100 and MI300A. So the speed up will be architecture dependent, but a decent speed up there for inclusive scan. Next slide. We've reduced the tooling interface overhead. So previously, we would need to compute the information of which tools were enabled for every single event. So for every parallel 4 or fence or similar, now we just store that information that we then can query during the events. And so it's most notable in small serial kernels. I think the motivating example for this was a user wanted to launch these small serial kernels like thousands of times. And so they were noticing that it was slower than expected. And so we see like a reduction of about 10 nanoseconds per kernel launch. So small, but decent reduction in the overhead for the tooling. Next slide. For SIMD, we added remaining compound.
Conrad, you muted yourself. I think you have to unmute again.
Apologies. Can you hear me now? Yeah, sorry about that. Yeah, for SIMD, we added some remaining compound assignments, which we listed there, and then we've added reductions. And so we have the reduce min, reduce max, and then we have reduce, which takes in a binary operator, which defaults to std plus, but also std modify, bit and, bit or, bit XOR. So those are added for SIMD. And then next slide. So we've improved the performance of some of our algorithms. So in 4.5, we fixed the performance bug in Kokkos source. The root cause of this bug was actually an implementation detail in the random access iterator. So for 4.6, we've reverted the fix for Kokkos sort and instead fixed the root cause. And so this fixes any algorithm that relies on random access iterator. So previously, we've seen sort in Kokkos 4.5, but now we have some results on the next slide for search. The performance improvement is going to be algorithm and hardware dependent. So here for Intel Skylake, for the Kokkos search, we see that we have as we increase the number of elements, we have a fairly significant improvement between 4.5 and 4.6. And then next slide. We've added output to print configuration if the system is allocated if the system allocated memory is accessible on the GPU. So we have an example here of what the output would look like for MI300A with a HIP backend. And so, yeah, you see that last 2 lines there. And we wanted to note that there's no guarantee on this print format that this could change in the future. Yeah, just important to note. But yeah, that's all for the general enhancements.
Whose turn is it? Patrick, are you online?
Can you hear me now?
Yep. Go ahead.
Okay. I will go over the backend updates. Can you please go to the next slide? So for the SQL backend, we improved sorting performance for non-continuous views. And for the serial backend, we reduced fences overhead when using Kokkos enable atomic bypass. So you have to check for this environment variable. And for CUDA, we improved performance for Kokkos parallel reduce on the H100, the new Grace Hopper chips, and newer like Blackwell by removing limitations on the runtime thread configuration. And on the next slide, I think you will see some benchmarks here. And on the left side, you see some computationally cheap kernel, and then you see the runtime relative to 4.5 in the latest release. And then you can see if you have a computational cheap kernel and you have not enough elements, so you have less elements. Here you see they are on par, the V100 and the H100. But if you increase the size of elements, you can see a good difference here. And then on the right-hand side, we have computationally expensive kernels here. And again, here for computationally expensive, for lower elements, there's a little bit of bigger difference as for the cheap kernel. And you can see, again, a bigger difference for the expensive kernel. And so this is quite interesting to have this new better performance for parallel reduce on the H100 Grace Hopper and the Blackwell QDEV GPUs. Can you go to the next slide, please? Then for the HIP backend, we changed the block size deduction to prefer smaller block teams if possible. Then we allocate memory with stream order semantics. For example, we use hipmalloc async here in this backend. And we also fixed the seg fault when a virtual function called inside a kernel requires too many registers. So this is fixed now and should work. Can you go to the next slide? And now this was all for the backend updates. And now we'll have a look at the build system features. So we added support for the Zen 4 AMD microarchitecture. So you can enable this with Kokkos_Arch_Zen 4 and compile for this one. And also for the NVIDIA Grace architecture, if you can now compile this NVC HPC. So we introduced this a while ago, Kokkos Arch RM49V9 Grace. And in addition, we support static libraries built via CMake CUDA runtime library static when you're using CUDA as a CMake language. So you can do this. Yeah. Okay. Next slide, please. And we also have some updates reported to spec because many people use spec to build Kokkos. And so in the spec develop branch, it's not in the latest release now. We support now the MI300A with a new variant APU. And if you want to compile Kokkos with MI300A support, you can just add spec install Kokkos as you would do before. You do plus rockm, and then you can put the AMD CPU target, and then you can add plus APU to have the APU support. And next slide. Yeah. That's all from my side. Thank you.
All right. I am next. So I'll talk a little bit about deprecations and other breaking changes. So if you can go on. Yeah, so one of the biggest things is that we are removing support for Intel Classic. So this is like the old Intel compilers that are that have been deprecated for a while now and were removed from one API last year. So of course, all of the newer Intel, like the client-based Intel compilers, we will still support. Next slide. So we made a few changes in this release to dual view, mainly with regards to safety of the dual view. So the idea is that we have deprecated the direct access of E view and H view because modifying these allocations can be dangerous, especially if you forget to modify or sync. So please use the view host and view device functions instead. So these functions return by value when there's deprecated code enabled and by constant reference if you do not have deprecated code enabled. So this could potentially have some performance implications. So please keep that in mind. Right, next slide, please. Okay, so if you're using the experimental SIMD support that we have in Kokkos, there's a few changes to further align with the SIMD in the C++26 upcoming C++26 standard. So we've removed native SIMD mask. Well, sorry, we've deprecated those because those were removed in the standard. We're removing being able to get a reference from SIMD operator bracket. This is also because in the standard this was removed because of various issues with reference proxies. And then finally, we've changed the return type of the comparison operators, operator equal, and operator not equal for SIMD types to return masks instead of bool. This is a little bit more correct. And if you really want the old behavior, you can just use the olive reduction over the operation. Next slide, please. Okay, so we've already discussed deprecating the makefile. So yeah, again, just be aware of that. And finally, the static CRS graph. We decided this would be more appropriate as part of Kokkos kernels. So we've moved that into Kokkos kernels and deprecated in core. You can see that pull request if you want more information about where it's located and so on. But long story short, you can access it under the Kokkos sparse namespace. All right, I'll continue on with some bug fixes. So in general, we fixed the issue with ranges with more than 2 billion elements. Also with Kokkos Graph, we fixed some node lifetime issues and fixed some issues with lock-based atomic failures, particularly with CUDA and HIP graphs. On the CUDA backend, we fixed some issues with the MD range policy with higher ranks for higher iteration counts. In the Kokkos experimental SIMD support, we fixed a bug in scalar min-max and a bug in non-mask reductions. Finally, if some of you have been using Kokkos on Windows, there was an issue with compiling on MSVC with Vue that popped up in certain configurations. Right. There's a few fixes to the build system. When we so now the clean target is properly called when embedding Kokkos in another project. We also added some. We made it an error if you have Kokkos Arch ARM v9 Grace specified to CMake, but ARM v9 Grace is not supported by the compiler. So you can still try and get sort of old behavior. You use Arch native there. We fixed Gen3 flag for NVHPC. We used the right architecture from i300A in the makefiles, which are going to be deprecated. And then when building with CUDA, we fixed some issues with GCC assembler options in the NVCC wrapper. All right, and finally, some performance bug fixes. There's some performance bugs that were affecting the atomic fetch star operations on integral types and on some long types of HIP, so we've addressed that. And we fixed the performance of range policy when there's an error message where we're generating an error message even if the precondition wasn't actually violated. So this should be a little bit faster now. All right. Yeah, so if you want to, I don't know if I should do the slide or you wanted to
go ahead.
over Demia. Okay.
No, go ahead.
Okay. So to if you want to get your own fixes and features into Kokkos, contributions are very much welcome. Please fork the Kokkos repo, make a topic branch, and then create a pull request. Including documentation, and of course you can always get in touch with us on the Slack at kokkosteam.slack.com.
Thank you very much, Nick, Patrick, and Conrad. So that concludes the Kokkos Core part. We're going to move along and go with Kokkos kernel stock.
Okay, hopefully you're just seeing one slide.
Yep.
All right. So my name is Carl Pearson. I'm speaking on behalf of the Kokkos kernels team. So sort of similar outline to the briefing you just heard. Our documentation is currently available here on GitHub and Kokkos kernels, though as I'm going to mention, we have some new documentation that you can build actually as part of the repository, and it's not quite hooked up to the Kokkos org website, but that should be accomplished shortly. And just like the general Kokkos org, of course, you can find us on Slack there. So I'll just get right into it. We've adopted the static CRS graph from Kokkos So there's a minor adjustment to the size type there as well. So this should be basically just a search and replace sort of experience for folks. If you're using the Kokkos static CRS graph somewhere, you can just use it from Kokkos kernels again with Kokkos sparse in the Kokkos sparse namespace. And we also have the compressed column store version. More generally, we have some enhancements. So one of the main things we've been working on this release is some new documentation. So you'll find that this is distributed with our source code now. So moving forward, we're not going to be updating the wiki that's associated with the repository. Instead, the updated documentation will just be distributed with our source. We'll probably host the latest tip of the documentation on the kokkos.org website. If you go up in the top right and hit documentation and go down to Kokkos kernels, right now it's still going to aim you at the old wiki, but soon we'll probably aim you at the tip of develop for the documentation. But if you're building with Kokkos kernels, 4.6 moving forward for a while, then the 4.6 documentation will just be in your source tree, and you can build the documentation there if you want. We're not quite done with it. We're still working on a few of the components, but BLOS and sparse and graph are all in place. And so there's just a couple of these ODE and batched components that are done. And just like we're happy to accept improvements to Kokkos kernels, we're happy to accept improvements or bugs for the documentation, right? So it's the exact same process as contributing or filing an issue against, the Kokkos kernels C++ source code. Other than that, we've done a few deprecations. So again, this is going to be kind of a search and replace style change, but we're moving matrix, sparse matrix addition and multiplication out of experimental. So you can just knock the experimental namespace off of the symbolic and numeric functions there. And similarly, these particular sparse preconditioners and solvers, so the triangular solver and the ILUK, again, with this sort of symbolic and numeric and solve functions, just take them out of the experimental namespace. So any further changes to these public APIs, we'll go through the standard deprecation kind of process rather than just changing them however we want. So again, also some of these guys, so Gauss-Seidel, symbolic and numeric, forward and backward, and symmetric apply. We have a couple macros that we defined that we deprecated. No one was using these in Trilinos. No one's complained since we deprecated them, so we think no one was using these. But the way we define them, they were technically in the public namespace, so we're deprecating them, but there's no replacement. So if for some reason this is a problem for you, we would be very interested to, hear about it, and we'd be happy to accommodate it. So these are all batched. And similarly in sparse, we had a sort of wrapper for CU sparse calls that was used in one place in Trilinos. So we've patched Trilinos to get rid of that. We're not planning to maintain this as part of the public API. You can look at the implementation of this is relatively straightforward for you to move in tree if this is the kind of thing that you were previously relying on Kokkos kernels to provide for you. And then we've had some batched updates that I believe were contributed by Yuichi. So we have some general sort of matrix solvers and operations here that Yuichi's contributed. I'm not going to pretend to be an expert on these. If you're interested in them, you can read them off the slide and use them. So we really appreciate this kind of contribution. But it looks like we've got some rank 1 operations, LU factorization, general system solved that was previously factorized. And so Yuichi provided this diagram too for the kinds of matrix structures that are supported for the various operations. And we have some enhancements to some previous functionality that we had where we discovered certain assumptions about the matrix size or something was, not quite right. And so we've done some fixes and test and improve the testing of some of these. So if you were previously having problems with some of these operations, batch gem, TRSV, TRSM, TBSV, PBTRF, PBTRS, and serial QR, if you were having some problems with those before, feel free to give them another try. Hopefully we've ironed out any problems that you were having with them. And previously we had some implementation details that were in the public namespace that we've tucked away in Impl. So that's all we have.
Thank you, Carl. Okay, so that concludes the presentation part. If you had any question for us, feel free to unmute yourself and ask it. I have a question for you guys, and would you, out of curiosity, would you use the reaction under the reaction button, the raise hand, if you're coming to the KUG next month? Okay. I'm gonna assume that if you didn't raise your hand, you either didn't find the button or you're about to register. Good.
Yeah, on my side, I didn't find the raise hand.
Good, Amadou. Well, looking forward to meeting you.
Thank you.
Okay, well, if you guys don't have any question, then I would say we just close early. I'm gonna stay a few more minutes. If you were just too shy to ask in front of everybody, you can still grab me. But otherwise, we're done. Thank you, guys.
Just an offhand question. Are there
Yeah.
any planned like a roadmap for the next version of Kokkos, or is it sort of just all organic development?
You mean about what's coming, the changes?
Yeah, just
Yeah,
things that
so
you worked on that.
yeah, that's a good question. The main thing, which if we complete it, let's say perfectly, should be transparent to you, which is quite major. It's refactor of all the view internals to be using MDSpan directly. It's some major work, and so if we if we complete it well, it should be transparent to you.
Awesome.
But yeah, besides that, maybe the last few batches of deprecation, because that's the last opportunity, before 5.0 to get rid of baggage. But other than that, there is nothing that I would call major that's coming.
Okay. Thanks.
Improvement here and there. Hi, Christian.
What boy?
Said hi.
Hi.
Okay, I'm getting another call, so I'm gonna leave. Bye, guys.